figure out which line is the correct line. It's not a vertical line. The y-intercept is greater than -3. The slope is less than 1. It's perpendicular to another line on the graph, and it's parallel to any line with a slope of 0. So think about those. I'll give you a couple.
D.
Why D?
Because the slope is less than 1, and a horizontal slope, the slope is 0. The y-intercept is more than -3, which is above, it's 2. It's not a vertical line, so it's not up and down. It's perpendicular to another line on the graph, and it's parallel to any line with a slope of 0, which is across.
D. Was anyone thinking something else? D was the correct answer. When I did this with another class, they thought one of these ones, I don't remember which one. I want to say E, because it's not a vertical line, the y-intercept is greater than -3, the slope is less than 1 because it would be a fraction. It's not necessarily perpendicular though, it's intersecting, but it's not parallel to another one. Right, so that was refresher on some of the stuff that we just talked about last class. So last class was to kind of introduce you to parallel and perpendicular lines if you didn't know what those were, kind of loosely talk about the definition. Today we're actually taking notes about parallel and perpendicular lines, so I'm going to have you write these definitions down first. For parallel lines, they are lines that never intersect, which we kind of mentioned before, but we said that they look like they're right across from each other. But we did talk about this. Algebraically, we know two lines are parallel if they have the same slope. You can also add in and different y-intercepts. Because it has to be both things. In geometry, when you talk about parallel lines, you'll be using this symbol. So if you would like to use this symbol, you're more than welcome to. For perpendicular lines, the definition, so we said it looks like they cross. The actual piece of that, they do need to cross, but they intersect at a 90-degree angle. You'll talk more about that in geometry, but they make a T, not an X. And algebraically, we know that two lines are perpendicular if they have negative or opposite reciprocal slopes. Or negative reciprocal slopes. So we talked about that as being the slopes are flipped and the signs are opposite, but we're just going to combine both of those things together and call them negative reciprocals. This is the symbol for perpendicular lines, an upside down T. And then the definition of negative reciprocals, a fraction that's flipped and the sign is switched. So if it was positive, now it's negative. Whatever the number is, you flip it upside down. If it was a whole number, remember that whole numbers are over 1. So we're going to do some examples of negative reciprocals, and then we're going to find slopes of different points and determine if they're parallel, perpendicular, or neither. Anyone still writing? I'll give you another minute. So if I said, what is the negative reciprocal of 3/4? What would you tell me? Negative 4/3. Take it, flip it. If it's positive, make it negative. Okay. What about the negative reciprocal of 2? Remember that this is already over 1, so this would be negative 1/2. What about negative 7/8? Positive 8/7. 1. Negative 1. This one's a little tricky. So we have 0, which is over 1. If I take that and I flip that, what would that be?
Negative 1.
No.
0.
Undefined. So they don't look similar, flipped, whatever, but you have to know that 0 and undefined are going to be perpendicular no matter what. Those are going to be trick questions. Great. So we're going to do a few of these and then go on to the next piece. For this, we are given 2 sets of points. In order to determine are they parallel, perpendicular, or neither, we have to find the slope of both sets of points and then look at the slopes. So, as a reminder, I'm going to put the slope formula off to the side. y2 minus y1 over x2 minus x1. Label them if you need to. So I'm going to do AB first. So we would have 6 minus 3 over 2 minus a negative 2, which would give us 3/4. Then we're going to do the same thing for CD. So that would be 3 minus 0 over 3 minus a negative 1. What would that slope be? 3/4. And then looking at these slopes, would these be parallel, perpendicular, or neither? How do we know they're parallel though? Because they are the same. So I'm going to put the symbol for parallel because I don't really have room, but you can do the symbol or write out the word parallel. Questions on that? Let's do the next one. Same thing, find your slopes for AB and CD. We have 4 minus 2 over 5 minus 0, which would give us 2 over 5. And then for CD, we have 3 minus 8 over 3 minus 1. Negative 5 over 2. And these would be parallel, perpendicular, or neither. Perpendicular, how do you know that? They're negative reciprocals. Okay, so I'm going to give you some, actually, I'll wait until we do number. Alright, so for number 3, same process. For AB, we have 6 minus 8 over 2 minus negative 1. And then for CD, 3 minus 2 over 3 minus a negative 1. So these would be parallel, perpendicular, or neither. Neither. They're not the same, they're not perpendicular, they're neither. Now, this is an obvious neither case because they're clearly not the same, they're clearly not perpendicular. But some other neither cases are, they look the same. So like I have 3/4 and negative 3/4. They have the same number, but one is negative, they're not parallel, neither. Or they look like they're perpendicular, that case, or let's say I had 2/5 and 5/2. They are flipped, but one is not negative. So those would also be a neither case. Okay. Questions on this process so far? We're going to skip 4, go on to the next page. Alright, there are just this one. So we're going to do 5 and then we're going to jump to something else. Alright, so let's do 5. We have 7 minus negative 2 over 0 minus 0. 9 over 0. And then negative 5 minus negative 5 over 6 minus 3. Not 10. Someone said it. No. Right now, looking at the slopes, what would you say? Parallel, perpendicular, neither? Okay. But 0 divided by 3 is what?
0.
9 divided by 0 is what? Undefined. So would these be parallel, perpendicular, or neither?
Parallel.
Perpendicular? Perpendicular. They're not the same, so they couldn't be parallel. These will be trick questions because they will not look the same, but you have to know to keep simplifying. Now, if they were both undefined or both 0, then yes, they would be parallel. If it was 0 and something else completely, like 0 and 3, or undefined and 2, those are neither cases. Right? So not only do you need to be able to recognize slope, parallel, perpendicular, neither from slopes, from points, but also from equations. So number 9, would those be parallel, perpendicular, or neither? Would these be parallel, perpendicular, or neither?
Parallel.
How do you know that?
So for the slope is the same.
And?
The y intercept.
Correct. So these are parallel. What about 10? How do we know that?
Because the slope is and the y intercept is equal.
Sure. The y-intercept doesn't even matter, but the slopes are switched and one is positive, one is negative. There are negative reciprocals, yes. What about 11? I heard 2 different things. I heard perpendicular and I heard neither. Why neither? Alone.
Because they're both the same. One's like a negative. Like they can't be parallel because they're both the same. Or they're not the same. And they can't be perpendicular because one's not flipped.
So they could not be perpendicular. This one is neither. That's what I was referring to earlier. That they may look the same, the 1/3 and the negative 1/3, but they're not parallel because one's negative. They're not perpendicular because one's not flipped. And then some of them you'll have to solve. So like number 12, let's solve that one. We have to get this one back in slope-intercept form. How would we do that? Subtract x on both sides. And divide everything by 6. We have y equals negative 1/6x plus 5. To solve the other one, what would we do? It's already over here. Divide everything by 3. So be careful because they may not be at the same spot when you go to solve them. So are these parallel, perpendicular, or neither?
Neither.
Why neither?
Oh, wait, no.
It's perpendicular.
Perpendicular. Alright, we'll do two more of these, unless we want to see some more. 15, parallel, perpendicular, or neither. What's our slope? What are our slopes here? 1 and -1. Are those parallel, perpendicular, or neither? These ones are perpendicular. So this one is not like this one because 1 over 1 is just 1 and -1 over 1 is -1. So these are negative reciprocals of each other. These are not. These are perpendicular. Okay, what about 16? We have to know the slopes of these two equations before we can think about are they parallel, perpendicular, or neither. What is the slope of y equals 6? 0. So here you have to know your Hoyle-Bucks. The slope of x equals -1. Undefined. So these are parallel, perpendicular, or neither. Perpendicular. If you need to, you could draw it out. So I'll draw a small graph over here. Y equals 6 would look something like this. X equals -1 would look something like this. They would be perpendicular. What if it said y equals 6 and y equals 5? Would those be parallel, perpendicular, or neither? They would have the same slope. What about x equals -1 and x equals 0? What? I didn't hear what you said. If I have x equals -1 and x equals 0, they have the same slopes. So you need to know the slopes of those in order to get those right. Okay. Questions on how we find slopes from the equations? Go on to the next page. Oh, sorry. Did we have any others that we wanted to see from this page before we go on? So it'll be a mixture of this and what we're about. So not the parallel or perpendicular or neither page we go on after that to the page that looks like that. So some of your examples, like on the quiz on the test, will look like this. Some will look like what we just did. So you will need to know how to do all of them. Okay. So this, we're going to be given an equation, and we're going to be given a point. It's going to be very similar to when we were writing equations from slope and a point, from 2 points. But now we're given an equation, we're given a point, and we have to come up with another equation that is parallel or perpendicular to the original one. So that's what we're going to do right now. Keep these in mind that parallel lines have the same slope, and perpendicular lines have negative reciprocal slopes. So first, you're going to be given an equation. Notice what it says. Here we're looking for something that is parallel. What do we know about parallel lines? They have the same slope and different y-intercepts. So keep that in mind when we do this. Because our new line has to have the same slope as this one. First, cross out this y-intercept, you don't need it. It will only confuse you if you keep looking at it. So our new equation is going to have the same slope, so our new slope will also be what? -4. So I'll write that off to the side just so you know that's the slope we're going to use. Or you can put m under the -4 that's already there. Then we have to remember our point slope, so I'm going to write that off to the side. Y minus y1 equals m times x minus x1. We have our point, which would be our x1, y1. We have our m, so we're going to put those into this equation. And it would look like y minus our y1 is 7 equals our m, -4 times x. You can either put -2 or just immediately change it to a plus. So previously I had you put minus a negative and then we would change it. You could just change this to a plus, or if you need to see it, you can still put the minus and then change it to a plus. How do we solve this? Y minus 7 equals -4x minus 8, and then minus 7. So y equals -4x minus 1. So if I'm comparing this to the original, it has the same slope, it has a different y-intercept. If I were to graph this, this would be parallel to the original and go through this point. What questions do we have so far? Make sure you're writing this down. So that's like basic level, parallel, nothing really changes, we just put everything into the formula. Then there's something like this, where we have to solve this first before we do everything else. How would we get this back into slope-intercept form? Subtract x on both sides. So -3y equals -x plus 9. Divide everything by -3. So we have y equals +1/3 x minus 3. This is not the answer to the problem. You only change the original to slope-intercept form. There's more work to be done. You cross out the y-intercept of that because you don't need it. If it's parallel, our new equation is parallel, what will our slope be?
1/3.
So I'm just going to label the 1/3 as m. You could also put it off to the side, either or, doesn't matter. So we have our m, we have our x1, y1. Now we can put those into the equation. So this would be y. I'm going to go ahead and make this plus once because it would be negative, equals 1/3 times x minus 3. Then the work is the same. Distribute. And subtract 1. What is our final equation? Y equals 1/3 x minus 2. Again, parallel to the original, that goes through that point with a different line in some. Questions on that one? now we're changing gears. Now we're talking about perpendicular. So just as before, cross out this y-intercept, you don't need it. But now we need to figure out what would the perpendicular slope of this be. Negative 1/2. So you have to change that first before you do anything else. If you put in 2 into your equation, you're going to get a wrong y-intercept. So you have to change that first. You have your slope, you have your x1, y1, the rest is the same. Put it back into your equation, solve. So y minus 3 equals negative 1/2 times x minus 4. So when we add 3 to both sides, what would our final equation become? Y equals negative 1/2 x plus 5. So again, if I were to graph this, I would see that this is perpendicular to the original, and it goes through this point. We're going to do this on Desmos here in a moment. Do you have any questions about the perpendicular example? Now, in this next one, very much like the last parallel one we did, we have to change the slope, or put this back in slope-intercept form first. So subtract 5x to both sides. We have 3y equals negative 5x minus 21. Divide everything by 3, so that y equals negative 5/3 x minus 7. Again, that's not your answer. We just rewrote the original. It has to be perpendicular to this one. We cross out the y-intercept. What would our new slope be? 3/5. So again, you have to change that first. Otherwise, your answer is going to be wrong. Then you have to do the rest of the work. We have our x1, we have our y1, we have our m. Put that into the format. Y minus 1 equals 3/5 times x plus 5, or minus 5. Distribute and solve. So our final equation should be y equals 3/5 x plus 4. This will be the most work if you get a problem like this, where you have to solve it first, then find your new slope, then solve it again. Do we have any questions on this process? Alright, look at the next page. Are there any you want to see, do, go over, have questions about? I'm gonna have you guys go grab iPads so I can show you this in Desmos, and I want you to try a couple of these, and then I'll explain what you're doing after that. So everyone go grab them. Alright, in Desmos, I'm going to show you how you can use Desmos for these types of problems. It's very similar to how we did this for the writing piece. So let's say we are doing, I'm just going to put back in some of the examples from the ones we just said. So like number 1, I'm going to type in the point -27. So everyone type in that point -27. You may have to move your graph. I'm going to type in y equals mx plus b in the next line. You should see something that says add sliders, add all. Now this one, if it's parallel, you know the slope has to be the same, so you could change the slope to be -4. Then you can move this until it goes through that point. Also, I'm going to type in the original. I'm going to do that wrong. Y equals -4x plus 1. So you can either hit play and let it move, or you can move it by yourself. So move that y-intercept until that line goes through that point. And that's a good way to check yourself for these problems. The same thing will happen if you do something like number 2, except you can either put in the original. So if I put in x minus 3y equals 9. And I'm looking at this line and I see that the slope is up 1 to the right 3. Then I can just change this. Oh, and I have to change the point. Most of these. I can change my slope. I can change my order of error to 3, -1. And then again, just move the b until it gets to that point. So that's how your parallel works. Perpendicular is basically the same. You just have to flip your slope. So we'll do one more of these, and then I don't remember if anyone did have questions on that page, and then I'll let you practice. So for number 3, you're going to change everything again. Put in the point, change the equation, change our slope. So our point is 4, 3. Equation was y equals 2x minus 4. The negative reciprocal of this we found to be -1/2. So I'm going to change the slope to be -1/2. You see that the lines are crossing, but it has to go through that point in order for it to be perpendicular. So move it until it will. how Desmos works to check your answers. Hmm. Graph with different one. Just give me that one. Right. Did we have any questions on that last page that we wanted to see you go over a question on? I want you guys to try these two problems, whether you use Desmos or do it algebraically, it's up to you. So number 6 and number 12, you can work together, use Desmos, use your notes. After you finish those two, I need you to raise your hand so I can check it. After you finish those two, everyone pause, because we're moving, they're not listening. After I've checked those two, you need to be either working in the notes, working on the 3 delta maths that are due today, or really just those two things. So more practice in the notes or working on delta math after you've done those two.